Hello? Okay, cool. Morning, everyone. Thanks for coming to my session. And yeah, before I start, I'd like a quick show of hands. Has anyone heard of this thing called Prometheus? Like this thing, yeah, okay, cool. That will be relevant later. So yeah, the title of my session is Thinking Outside the Classroom, Building an Edge Device to Monitor Atmospheric Conditions. Unfortunately, my co-speaker was unable to make it, so I'll be giving this talk on behalf of both of us. All right, so who am I? My name is Jubril Oyetunji. I like to describe myself as a developer who likes to write, not just code, but also blogs. I'm interested in all things cloud native, and I write Terraform providers every so often. Cool. So this is how this talk is going to go. We'll start by describing what, the why, how, and the results we achieved. Cool. So first off is the what. That would be NARSDA. Not to be confused with NASA, but back in Nigeria, we have the National Space Research and Development Agency, which is focused on space research in Nigeria. So about 2 years ago, they decided to start clubs, which is basically to foster interest in space research in universities. And my school was one of the few that was selected in Nigeria. Cool, so the why. This year we noticed my school was expanding, we were having more buildings, and we decided to pause some of the space-related research and take a look at problems in our environment. So that was the first reason we started this project in the first place. Diesel consumption was up as there were more buildings. We had to run a generator to power the school. Degrading air quality, it got worse, and people with allergies, such as myself and other club members, could notice that the air quality was worse. And in order to say we have a problem, we have to visualize and quantify the problem. Cool. So the how. The first thing we needed to do was build a prototype. We kind of had the problem in mind, or the problem we're trying to solve, but now we needed to build a prototype to prove, for basically a proof of concept. So we gathered these materials, an ESP32 because we're going to be doing things with Wi-Fi, temperature sensors for temperature sensing, DHT11 for sensing humidity. I forget the names, but we had a carbon monoxide and dioxide sensor. MQTT, if you're not familiar, is a message bus which you can use to publish and subscribe to messages. In this case, this was going to be sensor data, and the edge is basically this kind of Raspberry Pi. Cool. Yeah, so at this point, you're thinking, oh, well, this is fine, but where is the cloud native? Well, this is a real image of me suggesting to the entire club that we use Prometheus. And we have metrics, we have Prometheus, so we might as well bring in Grafana to visualize this stuff. Cool. So what we ended up with was an architecture that was something like this. We had the ESP32 and the sensors hooked up, and that was publishing all the data or the values it collected to MQTT. And I hacked together a horrendous Prometheus exporter to get these metrics into a format that Grafana can visualize. Cool. So the results were something like this. This isn't exactly live data, but what we ended up with is we're able to detect CO2 in the last hour and by how much it's gone down. We're also able to visualize how much data we've collected over a period of time. We're also able to display safety values for the air quality. And the idea here is we're going to deploy this device to various locations in school. And as such, if we ever have efforts to cut down on our emissions, we'll be able to visualize the changes, hence where the edge part of this talk came in. So what did we learn? Well, hardware is hard. There were many problems because a wire could be missing. There's no compiler to tell you you don't have the right wire plugged in. Networking for IoT is weird. You have an ESP32, You need to figure out how to get that onto the internet, but at the same time, you don't want this to be like exposed to the main internet. And yeah, networking for IoT is weird. Bonus is, I think in the talk about 10 years of Kubernetes, the speaker said, Kubernetes is also about the community. And I think this is true. I'm here because the organizers thought this talk would be cool enough, and I am able to speak about these things. And as such, for the club now, people after me would be able to learn about Prometheus, even if it's for the first time, and learn about cloud native one way or another. So that's what we learned. If you're hiring, we should talk. And thanks for listening.
Check, check.
Okay, perfect. Thank you so much for this talk. That was very interesting. I have a question related to security. I'm curious to know if you have explored any TLS encryption or stuff like that in your project.
Yeah, so security was not exactly top of mind because we needed it to work first. And I know this is really bad to say, like we needed it to work first before we thought about security. But what we did do is ensure that the network is closed. So the network we're using was like separate from like the main school network. And the Raspberry Pi we had that deployed to, I made sure like it was locked down and only the ESP32 could talk to it. So that was the most security we did.
So you said the goal was to deploy them all around the school. How many did you get out there? Did you kind of accomplish that? Did you?
Actually, we had just one device, but the idea is like if it's good enough, we will be able to replicate this. Yeah, so we just had one in one major area.
That's a start. That's all. Yeah, that's how you start with one thing, right?
Yep.
Do you have any pictures of the device?
Yeah, I actually didn't take any pictures. I forgot to take a picture, but I did bring like the Raspberry Pi.
Any more? Okay, that's it. Then thank you.
All right, thank you very much.